Hello, everyone. Thank you for joining this presentation. My name is Lin Li, and I am an IR analyst at LaSalle University. Today, I'm excited to share some approaches and strategies with you for using LLM, large language models, fancy words today, in IR, institution research, and maybe data science alike. So the objective of this session is to build a framework connecting the dots for us to think about how we integrate large language models into our daily work in institutional research, and again, data science maybe generally. So there are three approaches from my experience that I've theorized. The first is just using the chatbot, using the website of LLMs that I believe all of you might be familiar with, and we'll dive deeper into my experience and strategies of how to get the best out of the chatbots. The second approach is code-based implementations. And we'll dive deeper around the technical terms and based on your comfortability, and we'll ask questions there also. And the third one is integrated AI software, and I'll let you know what that means later. So for the first approach, we'll review the features and capabilities and compare different models' performance to better select the one that suits our needs the best. We'll understand the mechanisms of how an LLM is trained so that we can know the techniques to improve the performances. Finally, in this section, we'll identify the pros and cons of this chatbot code-free approach. And then we'll go through the second approach and demonstrate some examples using code-based LLMs. We'll highlight the reasons and considerations, especially compared to the code-free approach mentioned about the chatbots. We'll share resources if you are interested in developing your skills in this code-based approach. I'll reflect on my own strategies from my experiences using this approach. Lastly, which I believe maybe will be the future of the AI world and LLM, because I believe LLMs will be integrated into more and more software applications that we are already using. So we will review the currently developing field of these different AI tools. We'll share strategies on how to choose them, consider ethical frameworks, which is very important for IR. We are dealing with student data. And discuss how we as IR professionals, data science, data analysts, can prepare ourselves for the future with AI. So the first approach, the chatbot approach, is the web interface and applications. Maybe you installed it on your phone, so which I believe all of you have interacted with at this stage. Let me know if you haven't. So programs like ChatGPT are one example, like here, the screenshot. So we also have Gemini Cloud, Claude, and DeepSeek, and many other LLM models to use. They all have developed some sort of chatbot that you can use for free. And probably due to the competitive landscape right now, they release a lot of more features and develop a lot of capabilities, like such as reasoning capability that can solve more complex projects by developing step-by-step approaches. That's what they call reasoning. And they are now connected to the web, going beyond pre-trained data set, which we'll dive deeper into the different training mechanisms in order to understand how it works and how to improve its performance. In case you don't know, you can also customize usage of LLM with specific instructions on the role it plays. So it's just click the button there and you can play around with the role playing of this LLM. It has developed also a multimodal processing feature also, where you can upload images or audio or upload files. So I hope you already knew all of those new features and capabilities in this competitive kind of landscape of all the different LLMs. While we're excited about all the new features, we still face a lot of different models to choose from. You may choose based on your budget or the popularity or word of mouth or just attending this webinar, what I like, and maybe you are going to try it also. But how can we choose a model by systematically by focusing on our task, the features of our task, the requirement of our task at hand, and the LLM performance in terms of benchmarking systematically and maybe scientifically. So firstly, there are actually many developers, scientists specialized in AI. They develop those type of leaderboards, benchmarking different LLMs performance on different tasks. You can find these leaderboards by simply Googling leaderboards for LLM, and this is only one source of it, to see which model has the best performance for certain tasks. Secondly, I believe another even more important strategy for us is to gain an overall understanding of how LLMs are trained and where does a model comes from. This is important to understand, to better understand the leaderboard, first of all, and also to assess sometimes on your own. So this knowledge can help us grasp why they perform in certain way, why LLM perform in certain way for specific tasks, and why they are not as good as another model. Let's dive in the three different training stage of a LLM. The first step is training LLMs on a large unlabeled data set, which you might already heard about. Large language models, a lot of GPU, and it's really resource consuming, not environmentally friendly maybe. So the type and features of these data sets determines what data a LLM is familiar with. For example, DeepSeek, the famous startup, really emergent startup from China, might perform better on Chinese input because it contains training on a large Chinese data set, while Grok might be better. If you haven't heard about it, it's from the X, which is Twitter, maybe the same thing. So around social topics, maybe it performs better because it's trained on those Twitter social topics kind of data sets and discussions. So that's two examples. And after the model are pre-trained, they can be fine-tuned for specific tasks. For example, Copilot, which I love, the best, from my personal opinion, the best AI tool that you must try, is fine-tuned. Copilot is fine-tuned on labeled data sets for coding tasks. Because I'm a programmer, I'm still a beginner, but I love coding. So it might perform the best on your coding needs compared to other models or tools because it's fine-tuned on this smaller and specific task around coding. As one example, it now is embedded in like Microsoft Office's Excel and stuff, and we'll talk more about it in the approach 3 later. So after all that, that's the engineering side. And how do we have control in this? We do. So this is the in-context learning. So it demands careful prompt from us, from the user. And you might already heard a lot of people talking about prompt engineering. And it is important. And you're hearing all about this for tips on enhancing LLM performance with tailored prompts. And I recommend reading these posts from OpenAI. I'll share the slides later, so you can click the link. You do not need to type and memorize it. So I recommend reading this post from OpenAI. It lists a lot of practical tips, and it's from the science developers, so it must be true. So I also list a few tips on prompt engineering below the post link, but we can discuss more detail if you are interested. We don't have time to go through each one of them, but at the end of the presentation during Q&A, feel free to ask a question and we can dive deeper. So that's approach 1, and let's review this approach. Let's summarize. So you have free access, like we all have some experience with that, free access to tools like chatgpt.com, which I showed as an example, for immediate LLM use with minimal setup. It's ideal for quick tasks and brainstorming, but has usage limit, as you might hit a limit every day, and lacks advanced features because it's not the latest model. You have to subscribe. So that's what I'm going to also review, the subscription. So by subscribing, on the one hand, you get enhanced capabilities, higher limits, more token, and better performance. You're using the latest model, and you can choose from the different model, and you can try out and select the one you prefer. However, subscribing usually locks you into an ecosystem, one ecosystem, which may not be ideal if you want to try different models, unless you have the budget to subscribe multiple different models, but it's costly. That may perform better, like different tasks might perform better on different tasks. So you might want to have the flexibility of switching between different models. But with budget limit, you could not do that maybe. Also, it has recurring costs, like I mentioned, $20 per month, I believe. And for the pro users, it's $200 per month, I believe, for the ChatGPT. And it might not be the most cost efficient. Now, that's why let's move to the second approach, which might be a solution to some of the limitations we've talked about from the chatbot approach. The second approach includes 2 sub options, calling the API and local deployment. We'll dive deeper and explain what that means. So the API approach is cost efficient. It offers you access to premium feature, latest model at reduced cost. It's charged by usage. From my experience, a simple project might cost only a few cents, not even 1 cent, to a few dollars, $1 around that range. So you can try different models also by using multiple APIs from my multiple model, and it charges by your usage again, keeping your costs down. So you can thus try different model with the flexibility based on your task requirement and performances according to the leaderboard or according to your own experience. You can also gain access to the open world of open source Python community, where developers are creating cutting-edge solutions every day and updating the Python libraries, like DSPy, if you haven't heard about it. It can optimize prompt engineering for you. So you can only do much maybe, and with the help of some package like this, you might do better. And then resources, there's another LangChain, which is so popular, and I do not fully understand it. But from what I can see, it can be very useful for you to connect your institutional database with an LLM so that you can ask questions directly as an agent. So that's maybe the future, and we'll talk a little bit more about that, and you can ask the question if you are more interested in this. So resources will be shared if you are interested in learn more around those packages and frameworks in my next slide, I believe. So however, to use this code-based approach, you must be familiar with coding. So for some non-technical person, that might be a steep learning curve. But be patient. With patience and passion, you might achieve at least as where I am now. So another challenge is LLMs are not the best at handling sensitive data. And we'll dive deeper into the next approach, the local deployment, and compare that in terms of that sensitive and data security aspect. You can learn more about how to handling sensitive data with API calls in the resource section. And one of that is how to remove your data and how to do this thing called data encryption. So we can also talk more about in the Q&A. Now consider how to start as a beginner. I recommend using Visual Studio Code, VS Code, for coding, as it has many helpful extensions. And Google that, or like search a YouTube video if you want to really learn about it and get started. And then another tip is familiar yourself with Python packages. It's so helpful. And later I'll list some of the packages that's definitely very important if you're going to use this LLM code-based approach API. You also need to set up an API key, of course, on the LLM website of your choice. And it is crucial to read the API Quick Start manual to find practical code that you can copy and paste into VS Code for your first prompt, and slowly develop from there. So they give you a template and you still need to do your own job, but it's good to have a quick start, and the manual is always very important. So exploring the resources, educational platforms and search engine like Google and YouTube are my best friend. So they are invaluable for learning up-to-date implications, tutorials. You can use just a combination of different keywords, and also the second one I list here is the libraries. So you can also use the library names as your keywords to search. It's an open world of learning, a sea of tutorials. Lastly, it is always the community like OCAIR that contains collaborators, mentors, and peers with similar interests to connect and support each other to share knowledge like this. Here are some example tasks with a code-based approach that I have some experience in. You can achieve many tasks that are actually similar to the chatbot, but with the latest model and the flexibility of customization. So from ask anything, ask a personal trip plan, to survey design, to report generation, to like transform this visualization with the explanation, something like that. Qualitative analysis and also quantitative analysis. I'll show you one small example on that in a later slide. And for the quantitative analysis, as I slightly mentioned before, there is agent. People say you can build an agent and you can ask a question and boom, the answer is there. But I believe it's a little bit too progressive. So for me, I still use a conservative approach of build my own code for my project, for the every stage for my quantitative analysis, from cleaning, modeling, visualization, you name it, feature selection, stuff like that. I still write my own code, but I use the help of Copilot, the best AI tool for me that I've used the most to obtain the better performance of all. So you can do all this at a lower cost using API and access the latest model of your choice, as I mentioned, and thus obtain better performance for your tasks. To show you how the implementation looks like, this is a lot, but this is an example of a survey designer I built using Python code in VS Code. So I first load packages and API keys. Then I define the files that I need the LLM to access to and to read about, including a meeting note. So it's here, including a meeting note that contains the survey request content. A meeting happened between IR and a client. And the template survey for how I want the survey to format look like. And the next chunk of code then connect to the LLM and generate the result. So here is what the result partially look like. And overall, I am satisfied, but as many of the survey experts here can realize, it is not perfect. For example, for me, we at LaSalle, we prefer the Likert scale option from negative to positive to avoid respondent bias to the order of the answers, due to the order of the answers. To solve this easily, actually, I can tweak my prompt. So on the previous slide, there were some messages I sent as a content here. I can simply add some kind of adjustment and instruct specifically requirement. I require the Likert scale to start from negative to positive, stuff like that. So it is still a lot of back and forth, but the good news is once I build my customized prompt and script using this LLM survey design assistant, as I call it, I can reuse this assistant, this script again for any other survey request. So it takes time to develop slowly to customize to your preference close to the perfection, but it's worth it because you can always reuse it. Moving to the local deployment of LLM. This is suitable for sensitive data handling because everything happens on your local machine. However, it still requires some programming knowledge and additionally a powerful computer. The more powerful, the better, with good hardware. It's somewhat required if you want the output to be generated very fast. So better GPU and resource you have from your IT or from your own computer, it costs a lot of money to buy a GPU, a highly efficient GPU, but this is the cost and trade-offs. Also, you might consider performance trade-offs with this local deployment approach because whatever you can download on your own machine, it's quite small compared to the real large language model. It's the distilled version of the model, so it might not match the API approach, which uses server-based, whatever the big tech company has, their GPU and a lot of resources. The original large model might perform better. However, if you are interested in the sensitive data handling part and a local approach, a local deployment approach suits your needs better because you are handling very sensitive data, I also would like to show you how to get started. So I recommend install Ollama or LM Studio. So the first presentation, Shilin mentioned she used LM Studio, but I used Ollama, but they are similar. It's just different software containing different large language model, open source large language model. And again, I recommend read the manual for whatever software you're using. LM Studio has its own manual, Ollama has its own manual. And if you are going to use Python code like me, read the Python package manual and guide as well on this GitHub repository. And some sample code here. So here, again, is the example for analyzing very simple basic stage of analyzing qualitative data. I only show this first step. I believe maybe this is the first step for any qualitative analysis, which is generating labels, highlighting the keywords, whatever you call it. So here I import packages again, and the Excel file containing raw comments from students in the satisfaction survey. I call the local model. So after you install the Ollama and read that manual, you will have a chance to copy and paste stuff like this, a chunk of code, and for you to adjust the message, the prompt. So here I just call the local model and generate the label result. I say, please generate some label in some format and group them together. The result looks like this. It does what I asked it to do, extract keywords and put them into groups. Again, very similar to the chatbot, right? But this is the local deployment, and chatbot also do not have the sensitive data. Like you are sending your data to the chatbot to the website. But here it's a local machine working for you, local LLM. So again, to tweak it to improve the performance, I can add more instructions and build upon this current version and for a more robust qualitative analysis, and for later stage if you want to do sentiment analysis, semantic analysis, but you need to break it down for the local model to understand it. And that's my preference and tips for you. Break it down and do not assume it can handle a complex task with one prompt and one try. So more tips on this. Reflecting on my experience, here are some tips. So testing different model for optimal solution for your task. Carefully evaluate the output and improve your prompt to generate better results. It's iterative. And take small, manageable steps toward complex goals. And lastly is continuous learning and staying informed about emerging techniques by using Google, YouTube, engaging with conferences, forums, and webinars like this, and community like OCAIR for discussions and connections and support. Like any other learning, you may experience a curvy, iterative road, but be patient with yourself and celebrate your small success. Give kudos to yourself by attending this session today and start small. It does not have to be that daunting when it comes to technical skills and the buzzword of nowadays, LLM. So this brings us to the last approach, integrated AI apps. So new AI tools are emerging every day. And this is a question asked by my boss. Among so many apps and services, how do we navigate and choose? We're making our next year budget now. So which one do we subscribe? Which one do we use? So to answer that question, it gets me thinking. And I roughly categorize the different AI apps into two groups. Ones that from established providers and ones that are emerging. They have different pros and cons in terms of their pricing, resources, and capabilities. But the most important of all, I believe, probably for us, especially in IR and handling with sensitive, sometimes like student data, is to carefully evaluate data security and privacy statement to ensure we protect our student data and carefully manage our data analysis with different levels of sensitivity. We can talk more about it in the Q&A. Among many AI tools available now, two of them, I've mentioned one, which is Copilot. Two of them that I really recommend you to try. So Copilot, which is now embedded into Microsoft Office suite. Depending on your Office license, though, you might not have the Copilot enabled because you don't have the most fancy license. But you can check with your IT to see if you can purchase that one. You may be able to use the power of LLM within your most frequently used Excel or Word, and you can Google or see a YouTube of the tutorial on how a Copilot works in your Excel. You'll be amazed by it. It's somewhat like an AI agent. You can ask a question and they do the work, they do the data analysis for you and generate a visualization if you ask it to do. Another is Notebook LM from Google, which is an excellent reading companion for me. It generates, you can learn more about it. We don't need to spend time on this. So more tutorial and demos by simply searching their name on YouTube as a tip. So I believe AI integration into softwares and platforms is the future of our industry and many industry maybe. There will be more development in AI agents that provide end-to-end analysis, but the current solution might not yet meet the claims. So we still have a role as IR professional and data analyst to play to guide the LLM to do reliable work, because nowadays AI agent is not reliable. This is from one of my mentors inside the big tech developing LLMs. So finally, we must consider ethical frameworks and develop institutional standards for responsible LLM implementation. Consider data privacy and protocol regulations with FERPA protected student data, for example. Monitor output for bias, and because large language model, they are trained on representative data, but how about unrepresented groups? So we need to monitor the bias, evaluate the output. And transparency matters also, and community engagement for building ethical practices and implementations with LLM. So these conclude my presentation. We went through 3 different approaches of using LLMs and evaluated their pros and cons. I demonstrated some sample code and reflected on my own journey that I hope can help you as well. If you are interested in learning more, aside from referring to this slide and the resources I shared before, which I'll share the slide, along the way during my presentation, feel free to reach out to me. I am open to collaboration if you have a project in mind, or you need some help with staff training, or you getting know more about some part of this presentation, or a consultation or something like that. So, but if you do not have a specific project in mind, you are always welcome to follow my YouTube channel, where I occasionally share my learning journey with the public. Thank you for your interest, and thanks again for OCAIR organizing this virtual conference and give me a chance, because I missed the AIR forum deadline. So this is my only chance if I want to present at AIR. Now I welcome any questions. And for here are some discussion questions you might consider. I'm particularly interested in knowing if you'd like me to demonstrate more on a specific task, so that I can improve my presentation even better. So I aim to improve the presentation, especially if I am selected as the best presentation and can present this important topic and tips again in May in Orlando at the AIR forum. Thank you very much for your support. I appreciate your time and engagement.
Thank you, Lily. As you were presenting, I received a question asking if you were willing to, and along with the other presenters, are willing to share your slides. And I think you already said yes to that question, so thank you. Any questions, comments for Lily? Please feel free to unmute yourself. I see Yung